SwayamPrabha. Digital India. Educated India.
So, minimizing material cost, a few tips are there. So, you always try to choose the cost is the major parameter. If you have a cost which is economical, so then the product is going to be the cost to customer will not be very high. If you choose a product which has a material cost very high or the processing cost very high, it is going to affect its performance or its sales performance in the market. Okay. So, minimizing material cost. So, there are a few tips we are giving here. Commercially available mill formed should be used to minimize in factory operations. So, basically what we are trying to say is you go to the market, find out whatever is very easily available, choose those material, come back, tweak your design little bit and make sure that it meets out the customer requirement. So, if you use a commercially available one, then the success of your product is going to be very high, the cost of your product is going to be low. And whenever you try to give a design, try to use the standards which are already available in the market. So, standard stock shapes, gauges, grades or formulation should be used rather than special ones wherever possible. So, that is why we try to standardize the screws and bolts M1, M2, M3, M4 and shafts. When we are there, we get half inch shaft, quarter inch shaft, 1 inch shaft or 20 millimeter shaft, whatever it is. We get it according to the standards, and when we have a nut or when we have some mating component, that dimensions also we get it accordingly. So, it is always good to use easily available material, it is always good to use a standard material. So, you do not have to worry much. Just for your information, the price of a computer falls down drastically year after year after year, but an automobile cost does not fall drastically year after year after year. Why? Because in computers they have established standards. These standards are given to every vendor and they say if you want to make a computer, your computer should have all these standards to be followed. The shape standard, size standard is given. So, if you want to make a laptop, so they say your laptop should have a serial port which is used for giving a thumb drive of this standard size. And the other standard which is given to all those people who manufacture thumb drives, they say if you are manufacturing a thumb drive and that shape should be finally this. You can have and the memory that is left to you, that is your capability, but when it gets attached to a laptop, this is how it has to mate. So, now what has happened, the standards are given. So, there is huge competition and people work on those standards and come to the market. So, whoever gives it at a better performance, lower cost succeeds and goes forward, and the rest of the people over a period of time die. So, it is only because using the standards the computer price or the laptop price falls down drastically. The material should be selected based not only on the operation environment, but also the temperature to which the product is exposed during the manufacturing process. For example, polymer, if you say a polymer has to be machined, the polymer predominantly can withstand up to 100-150 degrees Celsius. So, when you try to machine, the temperature always goes above 150-160 degrees. So, what happens is it tries to distort the material while machining, but in real time it can withstand the temperature. Or I will share a recent experience what I had. We were trying to drill holes on rubber sheet for developing a setup. So, when we were trying to drill the hole, the rubber on the rubber material, the hole was perfect. 6 millimeter hole has to be done, we got 6 millimeter. And over a period of time, maybe after a day or so, this 6 millimeter always used to become 7 or it used to become 5. So, we were not able to understand why is this variation always happening. Then later we realized that while machining there is a temperature, this temperature induces thermal stresses and this thermal stresses relaxes over a period of time. So, there can be a shrinkage or expansion of the whole geometry. So, that is what we are trying to say. So, if you are trying to use a material and if that material has to be machined or processed, for example, injection molding. In injection molding what we do? We increase the temperature, convert the solid material into a viscoelastic material and then we inject it inside a die. So, when we do that also there is a temperature phenomena which is involved in the process, and once you inject it into a die and if you do not hold it for some time, while holding it you also try to cool it. If you do not do this properly, then as soon as the product is made and left in the free atmosphere, it tries to get distorted. So, this is what we are trying to say. So, the 3 tips are going to be: the commercially it has to be available, you have to always use standards and you choose a material which does not get distorted while manufacturing. So, here are a list of materials we have displayed. So, all these things are metals and we have given also the processing temperature. So, you look at it, epoxy is around about 95 to 290. If you look at carbon, it is 3700. That is why all the high temperature applications we always go for carbon. So, if you are looking for a crucible which has to be kept inside a furnace, the furnace temperature might go up to 1800, 2000. We always go for a graphite or a carbon crucible where in which the component is made. You can also have tantalum, but it is expensive. Tantalum and tungsten are expensive. If you look at the lower side, all the borosilicon are nothing but the glasses, soda lime glass, it is 290. Polyester, which is a polymer material. So, soda lime is around about 290 degrees Celsius. That is why you see in a chemistry lab they always used to work on glasswares, because if they want to make a airtight setup, so then they always use glass and then they go either for seal it or they use glass, deform it to make the shape. Okay. So, if you look at steel, it is given at very high temperatures. When you look at this place like ABS and all, it is 60 to 80 degrees, 60 to 100 degrees Celsius. So, ABS is one material which is used for rapid prototyping, wherein which you have an FDM process wherein which a wire is used, polymer wire is used. ABS is one material which is exhaustively used. So, looking at this, you can choose material for your choice. So, it is only talked in terms of temperature. We have not put cost. This is only one variable. Cost is another variable. Third variable is the manufacturing it. Fourth variable is the physical properties. Fifth variable is the lifetime, or that is lifetime efficiency. For example, polymer cannot withstand very high temperatures and fatigue look for a longer time in rapid prototyping, whereas rubber can withstand for fatigue cycles. So, some design recommendations we are just giving it for your knowledge. So, when you talk about ferrous metals, cold finish steels, avoid holes, avoid grooves and the avoid undercuts, they are very expensive. So, this is feasible, cutting it under go is possible. This is less expensive and this is very much preferred, but here you will have something like a dovetail, this is also feasible, but manufacturing this is expensive. So, if you want to have sharp corners, it is not advisable because the stress can grow, and second thing, when you want sharp corners to be manufactured, it is very difficult. So, it is always advisable to give a small radius at different corners, so that it tries to make. So, this is a L angle, okay. These are all rectangle channels, cylindrical channels. You can, this is made out of copper, this is made out of aluminum, steel is also there. You can get these are standards which are available. You can get a rectangular cross section, you can get a circular cross section. Rectangular cross section with varying aspect ratio can be a square. So, you get that also. You get a solid shaft, you get a hollow shaft. So, you can get for varying materials. So, these are all standards which are available in the market. So, use standards rather than special shapes, which I have already discussed. Avoid sharp corners, as they are stress concentrated points, but on top of it their manufacturing is very, very difficult. So, when you try to take the design classifications of ferrous metals, so the ferrous metals are classified into pure iron, then for steel, then for cast iron. Many a times this pure iron and all, they do not pure metal does not have any functional application. They always get mixed with an alloy, so that they try to have some properties, strength properties or conducting properties, whatever it is. So, here you see a wrought iron, which is where the carbon percentage is less than 0.1 percentage. So, here wrought iron is an alloy with a very low carbon content. It is commercially known as pure iron, but this has no use. So, we add carbon into it, and more of carbon we put, it becomes a cast iron. Cast iron is made by remelting pig iron. So, you get more than that. So, cast iron you will have classification in grey cast iron, white cast iron, malleable cast iron and ductile cast iron. See, here also you try to have varying cast irons. Depending upon your requirement, you use. Where is cast iron exhaustively used? Wherever you have heavy loads, for example, church bell are made out of cast irons. It does not corrode, it has graphite in it. So, if you play with the heat treatment properties, you can try to play with the microstructure and try to get varying requirements. So, when you talk about steel, the steel are again classified into three. One is called as plain carbon steel, low alloy steel and medium alloy steel. Of course, you also have a high alloy steel. The difference between these three is the difference in carbon content, which falls between 0.1 to 1.5, and anything above 1.5 goes to cast iron. So, here what I have done is I have put you the list. So, you can see low carbon, medium carbon, high carbon. So, this is all plain carbon steel, this is non-alloy steel, and here alloying elements are greater than or less than 5%. So, here you see that low carbon low alloy steels are there, medium carbon low alloy steels, high carbon alloy steels. So, here the difference between this fellow and this is the alloying element less than 5%. So, when you talk about medium, the alloying element should be between 5 to 12%, and the alloying element anything less than 12% you go on this steel. So, here we have given all these tools, steels and other things. Today, we talk about a new steel which is called as high strength low alloy steels. So, here which is now talked about in automobile applications, very high strength low alloy steel. So, here you have weathered steel, the controlled rolled steel, pearlitic reduced steel, dual phase steel, microalloyed steel. So, all these steels are different varieties which are falling under the category of high strength low alloy. So, it is a combination of plain carbon steel and low alloy steel. So, it can be considered to be intermediate between carbon steel and alloy steel is this, and this has a huge application today. So, I am just put you how is the ferrous getting classified. Again getting back into design recommendations. So, the groove deeper than 1.5 times the width of the part are not feasible. So, if many a times what happens if you want to have a blind groove. So, what generally people do is they try to make a through hole and then they try to put a closure and close it, one way of doing it. The other way of doing it, because they talk about something called as the aspect ratio. So, aspect ratio is nothing but width versus depth or depth versus width, whatever it is. So, you can try to talk, and anything which is greater than 1, it is very hard for a tool to get inside and machine. So, what people do the other way around is they try to enhance the width and then make it equal to 1 of the depth. So, here making high aspect ratio features is a big challenge, and if at all there is any, try to use this logic or try to change the width so that you get the output. So, grooves depend rather deeper than 1.5 times the width of the part are not feasible unless the bottom radius are generous. Avoid abrupt change in the cross section thickness. So, what they are trying to say is if you have something like this a step. So, what they say is rather than continuously changing, try to have something like a taper such that you try to get whatever it is, and finally, you have a stepped one here. So, that it does not have sharp edges and it does not have anything. So, avoid sharp change in the cross section as they introduce local concentrations. So, cutting a credit card by bending it. Okay. So, that is what is one of the things. So, you should always try to avoid having a change in geometry. So, when you talk about non-metals, there are thermoplast and thermoset. Thermoplast can be remelted and used. Thermosets are one time melt and use. For example, it is bakelite. So, you can see, and interestingly in polymers you can also have these are inserts which are kept inside the thermoset, and they try to make a product which meets out the customer requirement. So, when you try to work on this, there is not much to worry, the shrinkage is very less, but when you try to work on thermoplastic, there is going to be a huge amount of shrinkage. So, when you try to create a die, and then when you try to inject a component inside a die, a component is injected inside. So, you will try to hold it for some time, and you will also take into account for the shrinkage of a polymer. So, shrinkage on cooling and curing of thermoset plastics must be taken into thermosets or thermoplast must be taken into consideration while designing a part. Internal and the external undercuts should be avoided. So, so this is also a recommendation which can be followed for metals, but for polymers, yes, it has to be followed. So, here we have listed varying polymers, what is the percentage of shrinkage it can do. So, phenolic 1 to 0.1 to 0.9%. If you look at it, so here are 2 to 2.5 acetate, acetal is 2 to 2.5, and you can see PVC can go up to 5%. Polypropylene can go up to 2.5%, polyethylene can go up to 5%. See, these are some things which you should be very careful. Polycarbonate does not undergo. So, people try to replace from polyethylene to polycarbonate, polypropylene they also try to work, polyvinyl chloride, PVC flexible, it can go from 1 to 5%. So, almost all the tubes which are used for agricultural applications are made out of PVC, which is a flexible tube. PVC flexible, you can have transparent, you can have non-transparent, you can have rigid tubes, which is generally used for construction, civil construction we use a rigid tube instead of a flexible, and when we think of applications in the garden agriculture, we always talk about flexibility in the plastic. So, by the way, today plastics have taken over in the agricultural field. Lot of agriculture implements today are made out of plastics because it tries to have the flexibility, it tries to have the impact load, it is non-corrosive and it is light. To a large extent, people have moved from metals to this. When we talk about ceramics and glasses, ceramic part edges and corners should be generous radius, because in ceramics it is always prone to have defects. The defect density in ceramics is very high as compared to that of polymer and metal. So, here what we suggest, or it is suggested, is you should give a generous radius such that the crack densities, the sharp edges do not act like a stress concentration points, and the cracks can grow very easily, and here the cracks growth is not there, it is brittle. So, it can easily fragment into 2 pieces or several pieces. So, generally in ceramics what we do is we always try to say please be generous in giving the radius around. So, that is why if you see many components, it will always be made into circular, okay, or chamfer to prevent the chipping and the stress concentration points. The outside and the inside radius should be at least 1.5 millimeter to 2.4 millimeter respectively. So, when we talk about ceramics and glasses by manufacturing method, so you can take material and method, normal economic production quantity. Typically ceramics mostly machined is short to medium, technical ceramics mostly pressed is medium to long run, pressed glass are used for long run, blown gas are used for long. Blown gas is nothing but your bulb, incandescent bulb. Then flat glass are used for long run, white wares are used for medium to long, and refractories are used for medium to long. So, we have put various processes and their costing in developing these ceramic pieces. So, rubber is one interesting material, but if you look at the periodic table, there are so many elements there, right, and all these things are to a large extent you have metals, rare metals and rare earth metals and this and that. In the entire periodic table you will never have a slot for polymer, but today polymer dictates the world. 30 to 40% or even 80% of the domestic products are made out of polymers. Okay. So, in polymers we classify them into 3. One is thermoplast, one is thermoset, and the third one is elastomer. So, elastomer is pretty interesting. You see a rubber band to a tire for a plane. All these things are elastomers. Elastomers and the thermoplast, the only difference is the ductility, of course, the bond structure. But here you see elastomers, it can be used for making rubber bands. From there to a spectrum it goes, and it can go for making tires of planes. Huge friction, huge weight, impact load it takes, and it is very successfully used material. So, the hole should be shallow and should be as wide as possible, consistent with the functional need. Avoid through hole for small surface. If necessary, through hole should be at least 0.8 millimeter in diameter, and it can go and 16 millimeter in depth. So, I have just put all those because we had a recent experience of drilling of rubber. So, we have just put those examples, and this is also taken from literature. But elastomers are another set of materials which are becoming more and more common today, and they have a wide application from rubber band that is domestic to heavy loads. So, when you talk about rubber, these are different types of rubber. One is natural rubber, you have styrene butadiene rubber, EPDM, ethylene propylene diene monomer, then you have nitrile butadiene rubber, then you have thermoplastic rubber, polyurethane rubber, isobutyl isoprene rubber, then chloropyrene rubber. So, you can see here these are the advantages, these are the disadvantages. Look at the applications: natural rubber, tires, SBR you can use for tires, EPDM you can use for seals, NBR you can use for O-rings, and O-rings, whatever O-rings and hoses. So, there are two things: one, it is used in normal room temperature, another one is in vacuum. Whatever rubber O-ring which works in normal need not work in vacuum. Okay, but whatever works in vacuum can work in normal. So, vacuum, if you see O-rings are used in vacuum, the rubber is completely different. So, then thermoplastic rubber, your shoe soles are made out of thermoplastic. Polyurethane, you have cushionings, rolls, automobile parts are made out of polyurethane. Isobutyl isoprene rubber, which is used for making inner tube body mounts for automobiles, and then the CR rubber is used for making hose tubes and V-belts which are used. So, you can see these are the rubbers, these are the application, their advantage and disadvantage. So, you have to choose a rubber to your choice, you have to choose a rubber based upon your product. When we talk about non-ferrous, so till now what we have studied is, we have studied steel, then we went into polymers and ceramics, elastomers, and now last we will get into aluminium. So, we will take into non-ferrous metals. Non-ferrous metals most commonly used for secondary structure as well as primary structure. Primary structure means load bearing area, it is aluminium. In almost all the automotive structures today are made out of aluminium. And if it is more moving towards high performance, people have started moving towards titanium, which is much lighter, and people have started moving towards magnesium, which is much more lighter. But the processing of titanium and magnesium is expensive, so people are happy with aluminium. So, aluminium, again it is not aluminium, it is an aluminium alloy. There are several elements which are added to it to meet out to the requirements. So, aluminium is the largest possible bend radius should be done when forming and to avoid tearing. So, what we are trying to say is bend radius, largest bend radius has to be given, otherwise it will try to tear and then start failing. While attaching to other metal parts, the facing surface should be insulated to avoid galvanizing corrosion. This is very important. Many a times what happens, we try to butt aluminium with that of copper. So, at this portion there is always something called as a galvanic corrosion. So, this corrosion tries to destroy the material. So, you should always try to insulate the material such that this corrosion is not transferred. So, you have copper and brass. So, copper and brass, generally copper is a highly conducting material. So, we try to avoid machining, we try to extrude. Copper machining to a large extent is avoided. So, avoid copper machining, use extrusion and press forming to avoid loss of material, use stock size requiring minimum processing such that you try to get a output. So, this is you put your fingers inside. So, this is something like a tool which is used for your self protection, or people nowadays use it for just for fun. So, you put your fingers inside so that you get it right. So, copper and brass, brass is a alloy of copper. So, we try to avoid machining here. Titanium is one material which is talked about more in aerospace, biomaterial, and nowadays in automobiles. So, here when bending a titanium sheet, generous bending radius should be provided. The cross section should be 16 millimeter or more, the cross section thickness, whatever it is, because when you try to machine titanium, the heat gets accumulated at the cutting zone. So, next you have to provide enough generous draft angle, so that you can easily remove the material. Rib width should be 10 millimeter or more. Rib is what? So, you have a material, so you have several ribs. So, the rib width should be 10 millimeter or more, and the rib height should exceed 4 times the rib width. So, that makes it little stable. The fillet radius should be at least 25 times of the rib height. Zinc and its alloy. So, zinc is also nowadays becoming a little general to use for various applications. Bending is regular. Commercial rolled zinc should be at right angles to avoid grain or directional grain or rolling direction. The bend radius should be at least equal to the material thickness. The forging zinc used a combination of zinc and manganese, which put up to 25%. So, these are some of the nipples which are made out of zinc for various applications. This is a zinc alloy. So, if you see engineering materials, you have metals, ferrous, non-ferrous, non-metals, organic, inorganic. In organic, you have polymer. Polymer, you have thermoplast, thermoset, elastomers. This is a spectrum of material in each. And then when we look at organic others, we see the carbon, wood, fiber, paper, leather. These are all naturally available. Then when you talk about inorganic, we talk about ceramics, we talk about glass, and we look at others. When we talk about ceramics or high temperature ceramics, they are all alumina, magnesia, beryllia, carbide, nitride and stellite. So, carbide is silicon carbide, nitride is silicon nitride. So, these are all ceramic materials. When you talk about glasses, it is silica, soda lime glass and lead, which is part of glasses, and you have the other spectrum here. When you talk about ferrous, I told you earlier, it will be steel and cast iron. It will be plain steel, medium carbon steel and then cast iron. When you look at non-ferrous, today non-ferrous is picking up. Non-ferrous materials and polymers are picking up in the market. So, aluminum, copper, brass, bronze, zinc, magnesium, titanium, tin, nickel and lead. All these things are getting very popular today, which gives hell a lot of combined properties, strength plus thermal conductivity, strength plus corrosion resistance. So, it tries to give combined properties. So, non-ferrous materials are also thought about in a big way. So, the task for the students today is, you will try to take a milk cooker or a milk pan and try to analyze what is the material used. Next, what all possible materials can be used. Next, what are the latest advancements keeping energy as a prime performance. Next one, what is the maximum aspect ratio possible in a milk pan. What is aspect ratio? Aspect ratio diameter to depth. Okay. Next one is what all shapes can be made in a milk pan. So, that means to say whether circular, square, rectangle, oblong, etc. Okay. So, you are supposed to do this assignment, and when you do this assignment you will try to understand what is the big spectrum of materials which are available and how did you choose or what all can you make a choice. And here when I said latest development, today we talk about copper bottom vessels. So, please look at those options also. The bottom is made out of copper, it has a steel on top. So, what is the advantage? How is the performance varying with respect to energy, and then you also compare with cost. Right. Thank you very much.